So, I've made some progress on the bike. Because of the coronavirus and all of the things associated with it, I've got some time off of work, which means, obviously, work on this. So, I've got quite a lot done. As you can see, the controller is mounted now. There's some tabs welded on there. Just ignore the awful welds. Didn't really bother, because it's not going to be seen anyway. It's only got to hold this thing that weighs like 2 kilos. Heat sink's on as well. That took ages to cut. The heatsink was way bigger originally. That's on now. Some of the fins are a bit bent. I need to unbend those. Hey, you're probably thinking the controller's mounted now. What do these two cables do here? Why is there an Anderson 50 SB50 Anderson connector there? Now that's for the charger. Originally I was going to fit a 1.8 kilowatt charger, but if I take the seat off back here, if you have a look, there is a 3.3 kilowatt 96 volt TC charger back here. And as you can see, that doesn't look stock. As stock, these connectors are on there. If I don't drop it, that is. Because I actually want to reuse these for something. Now you can see, these protrude quite far. Just with that connector there, I don't think it'd fit in the frame. But you've got to think about it. There's a plug that sticks out to about here on that connector, so there's no way that would have fit. So I've actually taken the charger apart and replaced the connectors with pigtails for all the cables. Mains input is here, output is here. They're all shielded. That's what these little wires here are for. These are the shielding wires. So these are all covered in braided copper sleeving. You can see the shininess through there. This one's shielded as well. Mains cable is not shielded, as I don't think I'll need it. And then there's this thing back here which I'm really quite proud of. You can see all the holes I've drilled in it to keep the weight down. Didn't do a very nice job of that either. I might put one more up there. Doesn't look very nice, but from the top it looks absolutely amazing. Now if you're wondering what is this for, you may ask. This is the CAN bus. This is the programming port for the whole bike. Now to get this to fit under the seat, I would have either not had to have the ceiling cap on there, but I wanted that obviously, so I had to cut. The original hole in the seat came up to there, I had to cut that extra little bit out, and now that actually fits. But it is lovely because this is my programming cord. I'm dropping absolutely everything here now. Need to clean the workshop again now that the weather's nice. I might get down to it. This is the programming lead. On one end, you've got a DB9 connector. On the other end, you've got an Amphenol somewhat mil-spec connector. I don't know what the part number is. You can probably see it on there. 62 GB something 3-pin connector. And that just goes straight in there. I think that's quite fancy, to be honest, this little mounting block back here. There is actually enough room for a second connector. That's why I thought this came off the charger. If I don't use it, it's just going to sit in my room for 20 odd years. I might as well make use of that extra room and stuff it right next to the CAN connector for some extra comms, because the BMS uses UART and I want a UART port on it. I want just a regular UART port. I've actually got the display that came with the BMS, and if I haven't got a phone on me or the Bluetooth and the BMS breaks, I've got a debug port back here. So I'm going to stuff that on there at some point as well. Now if you look here, this port, this plug is actually, I think it's a touch taller, so I'm going to have to make a cutout on the other side of the seat as well, unless I put it straight right next to it. but then I won't be able to have both plugs in at the same time, I don't think. Or maybe I will. Hang on, let me just figure this out quickly. No, that should be enough room. I should be able to get away with both plugs in at the same time. But I think that's really quite nice because it allows me to have 2 or 3 ports for interfacing with the bike. Pardon me. But yeah, it allows me to have 2 or 3 ports to interface with the bike and just get some signals out of the thing. I'm not sure if I'm going to put any other comms ports aside from those on there yet, and obviously the Bluetooth. But then anyway, moving on from that, there's the controller right next to the charger. As you can see, the heatsink is currently actually held in place by the controller. There's 2 little bolts down there that hold the heatsink on. So the only thing the heatsink's supported by is this controller. So if I was to take these 2 bolts out, the whole charger and everything heatsink would drop off. But I need to mount this under here to the frame there, and on the other side the same thing, and on the bottom as well. It hasn't got to hold much weight. I think this is 4 kilos, and this is about the same, so it's about 8 to 10 kilos, including all the wiring and all that. Hasn't got to hold my weight because the seats touch here, here, and there. So my weight is actually supported by, or any the passenger's weight, rider's weight, are supported by these bars here. Luckily not by these things. So the heatsink will hopefully not break off. Oh yeah, I think that's all there is to talk about on the back end of the bike now. Aside from these things need to be cable managed a lot better. I'm also thinking, going back to that little port on the back, I'm probably going to have power ground, RX TX for my UART, then I've got 2 spare pins. Now, believe it or not, this thing actually has 2 separate CAN interfaces. This thing uses a 250 kilobit CAN bus. Now, that's not fast enough for what I want to do on most of this bike. Because I obviously want my displays to refresh quite quickly, and there's a lot of data going between the controller, the BMS and the charger. So there's going to be 2 separate CAN buses, one just to deal with chargers at the 250 kilobit. The second one will be running at 1 meg or 500 kilobits to deal with the controller, the dashboard and the BMS. Talking about the BMS, there's some bits of it here. It's only got 1 CAN interface, it's got 2 PCBs, so I'm thinking top board, stuff to interface with the BMS and the controller and the dash. Bottom board, DC-DC converter and a second CAN interface. Should probably talk a bit more about the BMS itself because that's something I haven't really covered a whole load. If I just remove the tank. There we go. So this is the BMS. It's a Chinese smart BMS. It's quite good. This will actually be taking the full charge current because if the charger goes wrong and decides to, say, put 134 volts into my pack, this thing can cut the current, this thing can cut the power and stop the charge. So it would normally send CAN bus to this saying the target voltage has been reached, cut the charge. If that doesn't work, then the BMS itself will cut the charge. So I've got 2 layers of safety that this does not get overcharged. There's no real heat sinking in here because this doesn't get that hot. I'm not sure about how hot it will get when it actually has 30 amps going through it. This only charges at 32 amps, so it shouldn't be too much. Considering that it's rated for 300 amps, it should be maybe 60 degrees, that sort of thing. And I'm going to fill this up with, what's it called, whisker gel, the same thing they use in electrical boxes. The re-enterable potting compound, and that should work quite well. And it will even soak some of the heat out of it, hopefully, and transfer it to the case. On to a bit more stuff up here. There's no dashboard because the original dashboard, it was really nice. I was actually thinking originally I want to keep the original Honda dashboard because it looks antique and I like the look of it. But it does not give me enough information. Also, there's not any room whatsoever. I was going to put a Sevcon Clearview display on this because I found somewhere where I can get them for a reasonable price. I cannot fit it because it's too big. So I then thought I'm going to redesign the whole dashboard. I've managed to get hold of some 2-inch mechanical gauges that are controlled via RS485, well not RS485, J1750 something. Some weird RS485 based protocol. I'm going to have to figure that out as well. One of them's going to display current, the other one's going to display battery percentage, and then in the middle there's a big, massive 5-inch touchscreen TFT that shows all the rest of the data that I want. And that should be about it on the dashboard. Obviously, that will talk via CAN. It will get all its data. I'm not the one that wrote the firmware or designed the hardware for this dashboard. What they've done is all of the data is gathered via analog inputs, and the only data gathered via CAN is the Sevcon settings. So, for example, the drive selects. So you can have Eco, Sport, and full power. Basically, that's all it can read. So what I'm going to do is redesign the firmware so it gets all its data via CAN, because I don't need to have external temperature sensors. This has 2 in the BMS and 4 on the cells. That has a built-in over temp. I'm going to put an external temperature sensor on this. That has a built-in temperature sensor. The motor has a built-in temperature sensor. So all of that data is going through CAN, which means I can actually gather everything I need over CAN bus, which means I don't need any external sensors, luckily. Which should make my work a little bit easier wiring-wise. So I should only have a few cables going to the dash. I'll have probably 12 volt out from the charger, so that the display's powered via while charging, and the BMS is powered while charging. Ground, CAN high, and CAN low. That should be everything I need. All the buttons obviously are going to be on the dashboard itself. It's a touch screen. All the settings will be done via that, so that shouldn't be a problem. I've also been working on the regenerative braking. As you can see, it ain't there anymore. There used to be a regen lever here. It didn't feel like an actual brake. So if you look at this, this is how a brake's meant to feel, but obviously with the regen lever connected straight to the pressure transducer, it just felt like a stiff brake lever. So what I've done is come up with a ridiculously overkill system of the brake lever pushes the fluid into a cylinder, which then moves a piston up, which has a spring acting on it, and some air as well. So it basically emulates a regular, maybe 2 to quad piston brake caliper. So it'll feel the same, but obviously the output signal will be electrical rather than mechanical. So that's taking a lot of work as well. I'm going to have to redo all the 12 volt wiring because I want to make some changes. DC-DC converters as well. I'm not sure where to put it. The contactor goes there, and it can't go on this side because the tank will touch it, and I can't bend the tank out any further, so I'm really not sure where to put that. There's absolutely no room back here. I've already crammed everything in. This just about fit. That was really close. The controller just fits. You can see that the frame is actually squeezing down on it there, which isn't really great, but oh well, I don't care. It works. There's literally these bits back here, and if that wasn't there, there'd be a tiny bit of room there, and that's all the room there is on this thing. So yeah, there isn't any room. Also, batteries. I've realised that I've messed up quite massively. So far I've said it's going to be a 96 volt 26S system. This is rather embarrassing to admit, but I've only just realised that one of these has 4 cells in it. I've got 6 of them. I mean, no, one of these has 8 cells. No, it does have 4 cells in it. I've got 6 of these. That's not 26S, that's 24S. So it's not going to be a 96 volt system, it's going to be an 88 volt system with a max charge of 100.8 volts. So that's really not ideal. I would have liked to run a way higher voltage because all of this This is designed to run 96 volt normal. It can go all the way up to 134 volt, which is 32S in this case. This is designed to run up to 150 volts. The motor can run whatever I want it to, really. The DC-DC, everything was designed to go up to 134. So, yeah. Now you will say I could probably buy more batteries, but I can just about fit 4 batteries on this currently. Just about. And that's really tight already. So I need to figure out where to put the other 2. This is going to be a tight squeeze, but it should end up working quite well. And once it is finished, it will be brilliant. I should be able to get it through the MSVA without any problems, because I've done quite a good job of most of it. I have cut the frame, I have modified the frame, so I have to declare that, and I'm not sure how that'll go. But I've obviously done quite a nice job on all the welds, on all the structural ones anyway, they're quite strong. I've cut these bits out under here as well, so the charger can fit, so I need to put some maybe 5mm thick support bars down between there, just a little bit like that on both sides, and then maybe a little bit here and a little bit there so that that can support that. And that should be about it, and I still need to drill some more holes in this because I've got a few connectors that I'd like to put on this. As I said, either this one or I've got some big 4-pin high current things, because I need an external charge port for an external charger, because this is only 3.3 kilowatts. I want a 6.6 kilowatt home charger. So I've made this. This is a custom charge port thing, 3D printed. Looks a bit stupid, but the next best thing is one of the Anderson proprietary thingies, and that costs £100 for 2 of the connectors, and I'm not buying those because that's ridiculously expensive. So I made that. That cost me, I think, it cost about £5, so that was quite reasonable in price. But yeah, don't know where that's going to go yet. I don't know whether I will put the external DC charger on. I've already made it, so I might as well. But I just don't know yet, because there really isn't any room. I need to start thinking about what's required and what isn't. But I can put a bunch of things back here. I can put another big 4-pin high current plug that can handle 32 amps back here, and then maybe I can still fit that. That can go, if I can get this in that hole in the end, which is wishful thinking. I have to cut a slot that way. But if that fits, then I can definitely still just about squeeze that big 4-pin thing in there. And then that means I would have an external DC charging capability. But I don't know, the 3.3 kilowatts should charge this quite quick, really. It should only take about, I don't know, 3 hours-ish. Something like that. 2.5, 3 hours, so I think that's probably good enough already. I've looked at some of the specs of an equivalent to this, which would be the Zero, or Zero's 125 model. 7.5 hours to charge, I think it said, and only a 700 watt charger. So I think this is definitely the way to go. And they only have half the capacity of what I have, so that's quite nice too. But yeah, this should turn out quite well, hopefully. And with there basically being nothing to do, because they are talking about the UK going on lockdown somewhat soon, I don't think there'll be anything else I have to do, so this should be finished by the end of the crisis, unless I need to buy something, in which case I'll have to wait till the end of it. But yeah, I think that's about it, and I shall be back with the next video. Will probably be about some of the modifications I made, just a short, maybe 5-10 minute video on how I modified that. The one after that will be either for the regen braking or the dashboard, but I'm really nowhere near done with the dash, because I need to write software. I'm not good at that. I'm good at making hardware, I'm not good at writing software. So I'll probably take my sweet time, 2-3 months with that. But yeah, that's about it.